Yes, hello. Welcome to my lecture video regarding to this introduction to piston pipette. So nowadays, pipetting is very common in laboratory, especially in COVID testing laboratory. So it is one of the main component or one of the main instrument that is used in the laboratory. So in this lecture, uh, I would we will introduce you to different liquid handling instruments. So after this, you can choose what is the most suitable instrument for your application. After that, we will define what are the accuracy and precision and how can we achieve the best measurements. So we will also educate you to pipetting system and pipetting techniques. So after this one, you will have an efficient pipetting. So we will also include in this topic are the several different properties of liquid that can affect the experiment. And the last one is how the pipette tips influence the result. And so you can have a good pipetting procedure. So we have under liquid handling instruments, so we have a different kind of liquid handling instruments from glass pipette to piston operated pipette. We have also automated pipette and Burette and Dispenser. So we go to glass pipettes, we have the common are the graduated, the volumetric and glass micropipettes. So this is the graduated pipette. So graduated pipette, which is a pipette with its volume in increments marked along the tube. So we have, if you can see, there's a marking or increments in the tube or in the side. So it will tell you what is the volume that you are aspirating and dispensing. So we recommend you to use graduated pipette whose size is the nearest to the volume being worked with. For example, if you will work with 0.5 milliliter of volume, the nearest available pipette is 1 ml. So it is also a recommendation that you need to rinse the pipette before use to prevent error. The next glass pipette is volumetric pipette, which allows extremely accurate measurement of the volume of a solution. So it is calibrated to deliver accurately a fixed volume of liquid. So if you can see, there is the label which determines what is the volume. So you can see from the side that is the volume that it is intended to. So the next in line is the glass micropipette. These are used to physically interact with microscopic samples such as in the procedures of microinjection and patch clamping. So I have a picture here of what is a microinjector. So if you will see, there is a microinjector in the left side. If you will zoom in, you can see that the glass micropipette is attached to the microinjector. So this glass micropipette is interacting with the cellular or any organism that you are operating with. The next pipette is an piston-operated pipette, which is an air cushion pipette. So this is the most common pipette, and this is our subject of focus for this lecture. So air cushion pipette consists of a piston cylinder system which performs the actual measurement. So if you can see in the figure, we can go back to the figure. So as you can see, there is an air cushion that separates the sample aspirated from the piston inside the pipette. So upward movement of the piston produces partial vacuum in the tip, causing the liquid to be drawn into the tip. The air cushion moved by the piston acts like an elastic spring from which the volume of liquid in the tip is suspended. If you will observe these figures, you can see that the piston has no direct contact with the liquid. So there is an air cushion between the piston and the liquid that makes it a very accurate with pipetting of aqueous solution. At the same time, there are also disadvantages of this type of pipette. So later on, we will discuss what are what are these properties that should be considered to avoid these disadvantages. So this one is the positive displacement pipettes, which are type of pipette that operates via piston-driven displacement. So unlike an air displacement pipette, which dispenses liquid using an air cushion in the pipette tip, the piston in a positive displacement pipette makes direct contact with the sample, allowing the aspiration force to remain constant all throughout. So the positive displacement principle, the piston of the tip is in direct contact with the liquid without an air cushion. Contamination of the pipette is prohibited with this one. So if you will see, there is the tip is bigger and it's like a side ridge type. So unlike in the air cushion, that's very small. And so if we will take a look closer look with this one, we can strip this positive displacement pipette and we can compare what is in the uh, schematic to the actual one. So if you can see, there is a black rod which is attached to the has the direct attachment to the pipette tip. So this is on this right side. So it's the same. So the black rod is the same with the right side. So you can imagine what does it look like in reality. So if we will see from the actual pipette tip, so it's like this. So now this is the semi-automated pipette. It is used to increase your productivity by pipetting whole 96 well plates at once. So using this, your pipetting will be faster and more precise. So now we go to fully automated pipette, which is commonly known as robot pipette. So this robot dispenses a selected quantity of reagent samples or other liquid to a designated container. So this one you can program the whole procedure in the monitor. Then it will do all the procedure. Then you can go for aspiration, dispensing. You can also do the mixing and everything as long as it is under the pipetting procedure. So we go to tap burette and dispenser. So we know that bottle tap dispensers are regarded as simple liquid handling tools to dispense defined liquid volumes into the vessel. So it's just like a transferring instrument from one big container to another small one. So the next is the tap burette, which is used for titration. So titration, we have during titration, using this one, you can see the liquid volume in the LCD. Then you can check what is the volume during the titration. So you will know when you get the result, then you can find the volume of that one in the LCD. So it's just a simpler way of titration procedure. Now this is now our overview for the remaining topics. So before going into the properties that affect the accuracy and precision, so we will define what is accuracy and precision. So accuracy is related to systematic measurement deviation, or also known as accuracy. It is a measure of the extent of the deviation or the difference between the mean value of the measurement results and the nominal value. So you can see in the in the illustration that uh, you can tell that the measurement is accurate if there is or small to none difference between the mean value and the measurement value. So when we said precision, it is related to random measurement deviation, also known as imprecision. Imprecision. So it is a measurement of variation of individual measurement values. So when we say variation of individual measured values, so the what the measurement can be accurate, but then it can be also imprecise. So how can we get a result like this? So we say, for example, you have measurement of we have five measurements of uh, zero point 0.5, 0.55, 0.45, 0.49, and 0.51. So you can say that this one is accurate one by getting the mean value. But then if you will see that the measurement 0.55 and 0.45, you can say that this one is scattered or imprecise as a whole. So we go to the first property of the defect in the precision and accuracy. So this one is density. So we know that air cushion pipettes are mainly used to pipette aqueous solution. So they are adjusted using distilled water as our reference liquid. So expansion of the air volume via the liquid variation depending on the density of the liquid. So this means that when we are pipetting liquids that are denser than water, the volume of liquid aspirated into the tip is typically less than the set value. So I have another illustration here with the formula, so we can visualize what I'm talking about. So I have a formula here, which is the volume equals to mass over density. Actually, it's derived from formula of density, which is density equals to mass over volume. Since we are using the water as our reference liquid during the setting up or the calibration of the pipette, so we will we will assume that uh, the density is constant. So because it is always referred to the water density of the water. So the varying or the variables here are the volume and the mass. Now, since mass of the new liquid is also a variable, we can get the mass by computing it from the given of volume and density of the new liquid. So let's say uh, meaning that mass is equals to volume of the liquid times the density of the liquid. So we can substitute that one to this equation, and we can get the the volume of the new liquid aspirated reference to the water. So actually we can simplify this one, and this formula, which is the V of the volume of the liquid is equals to the volume of the water times or multiplied by the density of the water all over the density of the liquid. So from this formula, we can relate it now to the table on the left side. So if the density of the new liquid is higher than the density of water, so what can achieve is that the volume of the liquid we aspirated is lesser than the volume of the water. Now we go to the property of viscosity. So it is indeed possible to process challenging liquids in a more precise manner using air cushion pipettes simply by observing a few tricks. The challenge with viscous liquids such as glycerol, for example, is the fact that due to their decreased ability to flow, these liquids are difficult to aspirate, and it is not immediately obvious when exactly the correct amount of liquids has been aspirated. So you can easily notice that air bubbles are quick to form and liquid residue remains on the inner tip of the wall. So the best ways to counteract this are to use slow aspiration and discharge speed, or to by or by using the reverse pipetting technique. So other lab technician, they do the trick of cutting the tip of the pipette tip. So you will have a bigger hole on the tip, then allowing bigger amount or larger amount of volume going into the pipette tip. So if we will observe this graph, so we have three line in the graph. So we have the first one is the forward pipetting, the second one, the magenta, is the reverse pipetting, and the third one is the positive displacement. So you can see in forward pipetting, there is so much imprecision going on. So there is the measurements are both inaccurate and imprecise. So it is very erratic or it's not consistent at all. So unlike in reverse pipetting, though there is still inaccuracy, but then the imprecision or the random error division, a random error is lessened. So it, it already focused on upper edge of the nominal measurement. So, but if we will look at the positive displacement pipette using by positive displacement pipette, errors are significantly reduced and accuracy is greatly improved. Now we go to the temperature. So temperature affects greatly. This one really is a very big factor in choosing a pipette, a brand of pipette. So pipette can affect your temperature can affect your pipetting in many ways. So first way is that the heat from your hand can be transferred to the body of the pipette, and from the body of the pipette it can transfer to the air cushion inside. So we know that uh, thermal expansion coefficient of air is high. So change in temperature in air inside the air cushion will greatly affect the liquid aspirated. So we can see from the graph on the right side there are two parts. So first part is that using or holding your bare hands with holding the pipets with your bare hands. So at the same time, on the right end is the effects of using gloves holding the pipette. So you can see from using the bare hands, you can see there is a great reduction of volume, meaning once once you transferred heat in the air cushion inside of your pipette, then the air inside the pipette will expand. So it causes the pipette to aspirate lesser volume of liquid. So unlike if you use a glove as insulator or heat insulator between your hand and the pipette, then it greatly reduces the error. So it has an upward trend, meaning that as time goes by, using a gloves, as time goes by, the 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 pipetting measurement is improved and almost going to the nominal volume. Now we go to the relative humidity. So it is very related to both temperature and vapor pressure. So relative humidity is the ratio of vapor pressure, partial pressure to the totality of the pressure. So and vapor pressure, atmospheric vapor pressure uh, also affected by the temperature. So these three uh, these three properties are interconnected with each other. So let's say you want to pipette and the air inside the air cushion is not yet saturated by moisture. So meaning there is a high relative humidity inside your your air cushion. So the tendency is once you pipette or you aspirated a liquid, the liquid inside the air cushion will tend to evaporate and go upward. So once you dispense this liquid, there is already an error in your in your accuracy. So you cannot you cannot tell it during the aspiration and dispense, but that once you measure it by validation, or by using, or by putting it on another container with markings and calibration, so you can tell that it is lesser than the amount that you expected. So our recommendation for this is do the pre-wetting. Perform pre-wetting for 3 to 5 times before doing the measurement. So it will greatly improve your temperature inside your air cushion, and by achieving the thermal equilibrium inside your air cushion will improve greatly your performance in pipetting. So we go to another property, which is the vapor pressure. So vapor pressure, we know that once moisture is already saturated inside the air cushion, then it is time that vapor pressure builds up inside of the air. So when it builds up, once you aspirated liquid, it forms pressure, static pressure, and this vapor pressure tends to push outward the water or the liquid. So it causes uh, drips in the tip. So the last one is the atmospheric pressure and sea level. So it is it doesn't really greatly affect the pipetting performance of, but it is somehow give small error. So the idea of this is at different sea level or at different altitude of the place, you will have a slight change in your measurement. So you need to calibrate it on your place. So go back to now. Let's go to pipette system and pipette technique. So I will not demonstrate how to do it, but then at least you will have an idea. So these are the difference between the two. So the pros and cons of using the air cushion at the same time, that's positive displacement. So we go to, so this one, why use positive displacement? So you can just read it one, or you can skip this one. So the idea of positive displacement is to eliminate the factors that affect in the air cushion. So it's just a review of our earlier discussion. So if you will see, this one has a direct contact, but the one who is in direct contact is the pipette tip, not the piston. So the advantages of using the electronic pipette. So this exact pipette can do a lot of operation like aspiration, manual dispensing, automatic dispensing, time dispensing. You have mixing. So if you know how to use this one, then it will be very convenient for your procedure. So it's a it is more ergonomic than the manual. So forward pipetting, so the this procedure is recommendable or recommended for aqueous solutions. Please do not use it for viscous solution. So how to do it? There is, if you press your pipette, usually it has two steps. So the first step you can try it, and the second step is the full press of the button. So in forward pipetting, you will you will push the button to the first step, then dip the pipette tip in the solution or in the liquid, then release slowly the push button. So by releasing it, you will aspirate the amount of liquid that you needed. Then to dispense, you need to press it until the second stop or the full stop or the full press. So that is for forward pipetting. Unlike for reverse pipetting, it is recommended for viscous liquid. So liquid which is very hard to flow. So the procedure was almost the same, but at, before you aspirate, you will need to press until the full press. So the second step, push it fully, then dip the pipette tip in the solution, then release slowly the bottle. So it will aspirate. But remember that it aspirated more than what you needed. So to avoid the inaccuracy with your measurement, it it aspirated more than what you need. So once you will dispense this one, you will only dispense until the first step. Then the remaining will be the waste. So meaning you don't need that one. So I only need this one. So you have a value that is more than you aspirated is more than what you needed. Then you will dispense only what you needed. So the remaining one is the waste. So this one is not famous with the lab tech because of this waste. So we go to the next topic which is the pirouetting, which already discussed earlier. So this one is under the pipetting technique. So we have also the pipette aspiration angle. So we recommend you to aspirate with 90 degrees or vertically. Do not do not aspirate slanted or with angle because uh, the lesser you will have the lesser gravitational force. So once you have lesser gravitational force, the liquid will go up uh, without any restriction. So you will get more than what you need, and we will get the measurement more than what you expected. So we go to the tip immersion depth. So this one is the recommendation is around 2 to 3 millimeters. So I hope you can practice this one. So it is very easy. It is not easy to measure the tip immersion depth, but at least once you practice this one, then you can estimate how deep how deep is your pipette tip during the aspiration. So this one, the uh, adjustment window, so adjustment knob. So this one will depend on the brand of your pipette. So this is for Eppendorf. So they made a provision that you can adjust your pipette to a certain number or to a certain measurement that will compensate to the volume loss during aspiration for viscous liquid. So this is only for viscous liquid. So you can get the exact value of the adjustment on the table provided with the pipette. So next is you should choose a pipette that has a low operating force, meaning once a low operating force is the force that you needed to press the button. So lesser operating force means more ergonomic or more ergonomic pipette. So it will help you to reduce the strain in your finger, in your thumb. At the same time, it is easy for you to do the procedure repeatedly. So it's a good choice. Now let's go to pipette and tip as a system. So don't be confused with this one. So many pipette are declaring their brand that is a soft open system, meaning their pipette is compatible with other brands or pipette tip. So we have the tip orifice. This this greatly affects the accuracy and precision of your pipette. So this bad orifice on the right side can cause retention in your pipette tip. So if you have retention, then meaning what you aspirated is lesser than the volume expected. So we avoid this one. Choose a perfect or a better pipette tip. So we go to the next slide, which is so this one. The idea of this slide or the idea of this comparison is to clarify that not not all brand of pipette is compatible to other brand of pipette tip. So my pipette, Epidur pipette or thermoscientific pipette may be compatible to only selected pipette tips. So this one. So we have a comparison. So please choose what is the best pipette tip or at least buy the same brand of pipette and pipette tips. So the first part, the upper part is the mean length of the pipette tip. So we have both for I think this one is 10 and 1000 microliter. So we have both 10 and 1000 microliter. So at the upper part is we have the mean length and the bottom part is the diameter. So if you can see, they should almost the same because we are talking about the same volume. So if we have 10 microliter, then it should have both. If they are almost the same with the diameter, then they should have also the same with the length. So it's like a volume comparison of volume inside the pipette tip. So we also this one the how they so this illustration is about influence of ceiling rim on the creation of an airtight system. So ceiling rim is the responsible for 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 the pipette tip to be an airtight. So if you have an airtight, meaning there is no tendency that you will have a drip on the pipette tip. So if you have not good quality of airtight, then air will pass through that. It will not hold the liquid inside the pipette tip. So it is a basic requirement of a tip to fit tightly on a pipette cone in order to generate an airtight system. So the term tip fit applies in two different contexts. Firstly, does the tip physically fit onto the pipette cone? Secondly, does that does this tip fit provide a tight sealing? So the physical fit of a tip onto a cone is mainly influenced by the design and shape of its contact zone with the pipette cone. The pipe the tip diameter is not the only factor. The connection between the tip and the pipette cone needs to be tight enough to prevent air passing through. If the tip is not tight, the system does not aspirate enough liquid and may leak. In the worst case, the pipette is obviously dripping, but incomplete tightness is often not recognized during daily lab work. So it is shown that the pipetting error increases by up to negative 0.6 systematic error and 0.8 random error with the generic tips used. So that is the idea of this sealing ring. So we go to the low retention tip. Low retention tip meaning that tip there is very small probability that there will be a retention inside the tip, a wall of the tip, pipette tip. So it is just so once you avoid retention, then meaning you have better measurement. So retention in the tip equals to inaccuracy of your measurement. So no retention meaning better measurement. This is the last topic for this discussion. So about retention. If you have any questions, you can leave a comment in the comment section, and we will try to answer every inquiry about how to improve your pipetting techniques. If you have any question regarding how to do the reverse or how to do the adjustment of pipette calibration, so you can leave any comment below, and I will answer to your inquiries. So thank you for listening. I hope you enjoy the video and you learned something from this. Thank you for watching. If you have any questions or clarification, please leave a comment down below. If you like the video, please like and subscribe.